Hello everyone, how are you doing? Today I'm going to be delivering the section number 4 on descriptive statistics and the section number 5 on statistical inference. So first let's begin with descriptive statistics. Most of the statistical information that we come across in newspapers, magazines, company reports, and other publications consist of data that are summarized and presented in a form that is easy for the reader to understand. Such summaries of data, which may be in the form of a statistical table known as tabula, or graphicals or numericals, these are referred to as descriptive statistics. So please let's refer back to the table 1, this table. So this table shows you data on 25 mutual funds. Just to remind you once again about something which is important on descriptive statistics. So descriptive statistics can be basically used to provide summaries of the information in this particular data set. Well, for example, a tabular summary of the data for the categorical variable fund type is shown in this table 1.4. Here, a graphical summary of the same data called a bar chart is shown in this figure 1.5. So these type of statistical tables and graphical summaries, they generally make the data easy to interpret. So referring to the table 1.4 and the figure 1.5, we can easily see that the majority of the mutual funds that are of the domestic equity type on a percentage percentage language, we can say that almost 63% are of the domestic equity type, 16% are of the international equity type, and finally 20% are of the fixed income type. A graphical summary of the data for the quantitative variable net asset value called a histogram, which is provided in figure 1.6. The histogram makes it even more easy to see that the net asset values range from $0 to $75, with the highest concentration between $15 and $30. Only one of the net asset values is greater than 60%, $60. In addition to statistical tables and graphical displays, numerical descriptive statistics are basically used to summarize data. And the most common numerical descriptive statistics is the average, or also known as the mean. Now, let's move on to the fifth section on statistical inference. Many situations require information about a large group of elements, such as individuals, such as companies, voters, households, products, banks, customers, and so on and so forth. However, because of time, because of cost, because of other important considerations, the data can be collected from only a small portion of the group, right? And the larger group of elements in a particular study is called the population, and the smaller group is called the sample. Formally, we use the following definitions. Population is the set of all elements of interest in a particular study, whereas a sample is a subset of the population. And an important point as well, which is that the process of conducting, a survey to collect data for the entire population is called a census. The process of conducting a survey to collect data for a sample is called a sample survey. As one of its major contributions, statistics uses data from a sample to make estimates and test hypotheses about the characteristics of a population through a process which is referred to as statistical inference or inferential statistics. As an example of statistical inference, let us consider the following example. The following study conducted by a company called Norris Electronics. So Norris manufactures or produces a high intensity light bulbs used in a variety of electrical products. So in an attempt to increase the useful life of the light bulb, the product design group developed a new light bulb filament. So in this case, the population is defined as all the light bulbs that could be produced with the new filament. So to assess or estimate the advantages of the new filament, 200 bulbs with the new filament were manufactured and tested. Data collected from this sample showed the number of hours each basically light bulb operated before filament burnout. So in the table 1.5, it goes to show you the number of hours until burnout for a sample of 200 light bulbs for the Norris electronic example. So now, suppose Norris wants to use sample data to make an inference about the average hours of useful life for the population of all light bulbs produced, or that could be produced with the new filament. Adding the 200 values in table 1.5 and dividing the total by 200 provides the sample average life for the light bulbs, which is 76 hours. So now we can use the sample result basically to estimate that the average lifetime for the light bulbs in the population is 76 hours. And the figure 1.7 provides a statistical summary of the statistical inference process for Norris Electronics. Whenever statisticians use a sample to basically estimate a population characteristics of the interest, they usually provide a statement of the quality or precision associated with the estimate. So for basically the Norris example, the statistician might state that the point estimate of the average lifetime for the population of new light bulbs is 76 hours with a margin of error of plus and minus 4 hours. Therefore, an interval estimate of the average lifetime for all light post produced with the new filament is between 72 hours and 80 hours. So the statistician can also state how confident he or she is that the interval from 72 hours to 80 hours contain the population average. So here we go. We've come to end. Thank you for watching. See you soon. Goodbye.